this is Microsoft Technologies for Data Science, and I'm going to call this Back Office Edition. And I'm happy to speak for this group. I've been to Charlotte a number of times for conferences, and certainly enjoy the city. Okay, this is a networking thing. So usually I have people introduce themselves to your neighbors. So go ahead and do that now. If you haven't met your neighbors, go ahead and meet them now. I'll give them that. Oh, by the way, Craig, how long are we going?
45 minutes. I don't know. Can you hear me?
I can now.
Okay. Well, we can hear you well, so we're anxious to begin.
Yeah. How long do we go?
Basically, we run until about 8:15, and we have a 15-minute break in between. If you need a few more minutes, that's fine too.
You mean 15 minutes before the 8:15?
In the middle somewhere, where if you come to a good stopping point.
Okay. All right. Let's go. All right. So I'm Mark Tabladillo. I'm part of the MVP program. I was at the MVP Summit also last week, and it was a great event. I think they had a record turnout for the number of people who came. We didn't have to pay for the conference, but we did have to pay for travel. And of course, for a lot of people, that could be quite expensive. People came in from Australia, Europe, Asia. So, people had to come on their own expense for that. But it was good to be there and have that hosted. This picture I took about a few years ago, actually. It was not 2013 when I took this photograph. That picture, the T-shirt, is the T-shirt that came out for the Azure Machine Learning. And I took my photo there with a picture of a flask. So my area is a SQL Server. We've been recently rebranded to Data Platform by Microsoft, so they're now combining a number of technologies for Data Platform, of which SQL Server is certainly an important one. And I've been also working with SAS for anybody who's been working with that technology. A lot of my career has been in consulting, and I've done a lot of training, teaching, and presenting at different conferences, such as TechEd, such as Past Summit, and also locally in Atlanta, and also some data science conferences. Feel free to connect with me on LinkedIn. You'll find me there on LinkedIn and also on Twitter at MarkTabNet. I'll mention that at the end. All right, so today, here's the outline for this presentation. So this is a technology outline. We're going to talk about SQL Server Analysis Services, the Excel add-in for that technology, Semantic Search, Microsoft Azure Machine Learning, and F#. Those are the main technologies. And I'm going to talk about some of the back-end implications. Let me talk a little bit about where I work. So I'm going to bring up a slide, or actually just the website. Okay. I work for a company called Predictix. Predictix is in Midtown Atlanta, and I happen to be right now doing this presentation from my office. It didn't turn out to be such a great idea because we've had connections on my problems connecting on my side because I'm using my personal laptop instead of my work machine. So I think next time we have to do this from home. But we are in Midtown Atlanta, and we are working with 5 of the top 15 global retailers. We work in retail, and we have about 140 employees split between our Atlanta office and our office in Tunisia. So I talk to people in Tunisia almost every day. And we work with high-volume data processing. One of our clients, we have to spin up 1,000 servers on the weekend to be able to do forecasting. And that's for 120,000 products at 7,000 retail locations, and we're doing that every week. And we do forecasts out for the next year. So every week we get a new feed, and then we have to go through and process that. And of course, this takes a team. I mean, we have a number of people that do different things, from running the programs to sharing the data feeds, and then also delivering it through our web application. We have our own technologies called Logic Blocks. Logic Blocks is a functional language. So if you've heard of Scala or F#. It's similar to that, but it's also a database. So LogicBlocks is a language plus database, and that's what we're using for our predictions. And our main offering is SaaS, software as a service, and that's what we're offering to our clients. So we're running those 1,000 servers. We're running on Linux, so our back end is running on Amazon AWS and also Microsoft Azure. And we're at a point now where our team that just purchases the server processing, they're now able to compete the different providers for best pricing. So we're able to compete Microsoft against Amazon, and depending on what our needs are for volume. But we're using both, and I think that does represent our use case is a good one for the type of processing we're doing. So here's some of the facts and figures. Hopefully you can see the screen. 5 of the top 15 global retailers, 60 billion weekly forecasts, and our claim of 200 million in annual benefits, and that's savings and or insights. Our company was ranked in Gartner again this year, and that's what this mention here is about. We got ranked last year and got ranked better this year. So that's 2 years now that Gartner's been interested in ranking our company and what we do. So I've personally been mostly a self-employed person, but working a lot with Microsoft technology. At the moment, what I'm working on right now is not directly connected to Microsoft, other than being hosted in Azure. But I think, interestingly, it does represent now Microsoft's new focus in being able to host open source solutions. And there's been certainly a different change in mind at Microsoft about Linux. There was recently a new Linux distribution released by Microsoft to be able to connect to Azure, and that surprised a lot of people. But there's also other open source technologies which I'll be talking about in this presentation. So I'm going back to the deck now. So how could data science apply? So let's look at some of the largest employers in the Charlotte area. And I guess right now, Craig, maybe we could go a little bit to an interactive exercise here. Does anyone know who the largest employers are in Charlotte? And maybe you can just, Craig, you could just relay some of the answers back.
Bank of America.
Okay.
Charmex Schools. Duke Energy. CMC Hospital. Charlotte Healthcare
CMC
System.
Hospital?
Yeah.
Okay, anyone else? I have actually the top 7, I think. Huh?
Lowe's, we heard.
Lowe's, okay.
Anybody else?
Anybody else got one? Okay, so I got this information from charlottechamber.com. In fact, the answer's right here. So if you went to this website, you'd see exactly the same information I'm just going to share right now. Okay, so these are the, so this is 6 of the top 8, and then there's 2 more. So these are number 3 through 8, and just in alphabetical order. So American Airlines, Bank of America, Charlotte Mecklenburg Schools, Lowe's, Novant Health, Walmart, and Sam's Club stores. What I like to start off with is just thinking through some questions that some of these employers would want to ask that maybe could be answered by data science. So let's just focus on the 2 largest ones. Carolina's Healthcare System and Wells Fargo are the 2 largest employers in Charlotte. Let's start with Carolina's Healthcare System, and maybe Craig, you could relay some of the questions, and really there's no real wrong answers here, but what are some of the questions that they might want to ask that might be able to be answered by data science?
Anybody have any questions?
I would say, how efficient are the operating rooms? Are they getting the patients in and out? I've actually been to a presentation, and I think they even looked through the weather patterns too, like to see the type of range.
So they're correlating weather with the outcomes? or usage?
In some cases, yes.
Okay. We were talking with one of our clients today about using weather data, and we're going to add that for this particular client to see if there's any connection between weather patterns and products that might be sold at particular retail locations.
You talk about American Airlines?
Any other questions for healthcare? Does anyone work in healthcare and have a question?
Nobody in healthcare tonight? Healthcare people didn't come in tonight.
Didn't come in. Okay, I'm going to give you some healthcare questions. One is, what type of professionals do we need to hire next year? Another question is, where do we need to build a new facility? Third one is, what programs are being undermarketed? Fourth might be, what technologies do we need to look out for? So those are some examples of questions. And questions that would be informed by data that you currently have, but also not completely known through some sort of query. All right, let's go with the financial one, Wells Fargo. Maybe easier because people maybe could formulate financial questions.
Are there any questions about Wells Fargo this evening?
Wells Fargo? Is anyone a customer in Wells Fargo? I have a Wells Fargo mortgage.
A couple of hands went up.
Couple hands?
Yeah. Any questions? I don't know, Mark, maybe you could help us out with some good questions.
Sure. So, questions for Wells Fargo could be, all right, let's ask an IT question. Who should get a tablet? That's a question. Sometimes people judge it on money. You know, you could also ask questions about your server resources and how people are using them.
I have another question, Mark.
Go ahead.
How many customers may be signed up for online banking, mobile banking, and whether
right.
whether that should be something provided to the additional functionality for customers?
Yeah. So yeah, the customers that sign up for different types of products. And sometimes companies want to come up with personas. So like they would know customers who like to do banking through their phone, or maybe they want to do it through a tablet, and they'll know, you know, how people log on. They could also ask questions about products, giving people relevant recommendations about different bank products. Investment products or changes maybe that refinance loans. That could be something.
Oh, okay. We have another question.
Uh-huh.
I think another question that may be asked could be in the area of privacy and security.
Yes.
Yes. They may ask a question about how do we manage security with this expansion of Internet of a Thing,
right?
With different gadgets coming in and going out. How do we secure data within the banking environment?
That's an awesome one. I mean, someone could build a whole business on that. So, Internet of Things referring to devices connected to the Internet, people's personal devices, but they also could be bank devices. So the bank would be concerned about where data is, how it flows. Are people authorized to transfer information? You know, when are they authorized to use flash drives? And security issues are certainly really important. And being able to track that too, that now that information can flow and they can track the flow of information, that could be used to be able to monitor security across the network.
Okay, I've got another
people's
question.
access.
As a previous employee of Bank of America, two of the hot topics was moving people off the BlackBerries to their personal smartphone using through an applet to access their mail. Another one was should they go to, you know, the standard was Windows 7. Should they skip 8, go to Windows 10, or wait for the next version to come out? It was always
Sure.
the same thing.
Yeah, and I like the computer upgrade question because, why should, a company of the size, and we're looking at the number of employees on the screen. I don't know the exact number because I didn't get it because it was just reported in a category. But you imagine 20,000 at the low end, upgrading 20,000 desktops. And, should they all be done now or can they wait? And what are the use cases? And people have multiple devices. What should be done in the multiple device situation? And not everyone's using Windows. So what should they be using? And, how should those processes go? Although I think in a lot of banking environments, I think Windows is pretty much well entrenched. There may be some Mac out there, but Windows has got a really strong foothold. Okay, let me go on. So thanks everyone for offering those questions. Reason I do like to do that is because in my experience in working in a lot of different companies or presenting data mining, one of the hardest things is to come up with the questions. And whoever's motivating the topic really needs to be the one that's motivating the discussion of what type of questions could be answered. And that motivates people to think about, what could be known. So data mining here, I've had different definitions of data mining: automated or semi-automated process of discovering patterns in data. And machine learning is another topic that we often hear, is the development and optimization of algorithms for automated or semi-automated pattern discovery. These days, the two terms are blending. And it used to be machine learning was something that people would program machines to go do, and data mining would be considered a human activity. And these days, people say they do machine learning. So it's like now blended in the last 2 years. So when I was in school with statistics or advanced analytics, sometimes you hear the phrase data science, but they're all referring to the same thing. I bring up all the terms because I do remember recently someone went to a presentation on machine learning, and then after the presentation they went looking for books. They couldn't find a lot of books. Then they discovered a lot of books have the phrase data mining in the title, and they're great books, and they're on the same topic. So it's good to know that the topics here, as far as books, good books that are out there or courses that are out there, often overlap these terms. This poll comes from KD Nuggets, which is a website I'll generally recommend. If you have your computer with you, you can look up kdnuggets.com. And what I'm showing on the screen is a poll from 2015. They do this poll annually. You can see the counts here. It shows in parentheses of what tools. The question here is, what analytics, big data, data mining, data science software have you used in the past 12 months for a real project? And they had 2,700 people respond to this poll, and they have the results here for the last 3 years, so you can kind of see trends and what people are using. The number one tool on this list then I'm going down the list now: SQL, Python, Excel, K9, Hadoop, Tableau, SAS, Base, Spark. And of course Spark has no numbers for 2 years ago because there was no Spark. So Spark's a new product: Weka, SAS Enterprise Miner, and Microsoft SQL Server. And what I want to emphasize on this entire list is that very few people use just one thing. And what I have noticed too for my colleagues or people who work in this field is just a need to learn a number of tools. One of the tools I think is really important is SQL. And a lot of people go to school for graduate data science and they never learn SQL in school because their tables are already given to them, are already pre-flattened, and they're already data cleaned too. So the data cleaning takes most of the work, really, and then the algorithms take a fraction of the work in terms of time. So the SQL is a great tool for that. Here there's a SQL NA here, but that's because they didn't ask it. Obviously, we know SQL is an old language, and it's been around a while. So I have some links here. I will have this slide deck available later, so you'll be able to have that. And so these links you'll be able to see in the deck that I'm going to make available. I'm going to go down the list here. I'm going to show you where Microsoft's present. So Microsoft's now supporting R. In the CTP 3 of SQL Server 2016, they enabled R to work with SQL Server. And the way it works is that SQL is now going to be able to call R in a separate process and be able to process R for a session. And of course, that's not released now for an RTP, but the CTP version has that right now. And I'm just going to say that, you know, look at that path for being able to do maybe more in the future. Right now, having that ability, what Microsoft's doing is they're trying to capture the mind share of what many languages are. Instead of rewriting everything that R does in SQL, because they could, but instead of doing that, why not just make a native connector to the R language where there's a lot of innovation going on, and that is really what Microsoft's focus is now. SQL is still going to be there, and it's a strong language in and of itself, but R is also important. And of course, in the last year, Microsoft acquired Revolution Analytics, which has a technology for scaling R for large data sizes. So Microsoft's also supporting SQL. Python is also now being supported through Azure Machine Learning, and also there's Python tools for Visual Studio. So people can now write Python code and submit it through a Jupyter notebook inside, that used to be called IPython, but Jupyter notebook, and put it into Azure Machine Learning and develop a web service. Excel, I'm going to show some. Hadoop is a big deal, and Microsoft's got HD Insight, which is a distribution of Hadoop, and then also running Hadoop inside Azure. Spark also will run on Azure, and so will Microsoft SQL Server. And even though I named those as Microsoft products, every other product here does run on Windows. They may run on other platforms, but they definitely run on Windows. So, you know, Windows is a great platform for doing data science, both in the front end and back end. Back end, we are going to see more solutions now hosted in the cloud. I mentioned one for my company with Linux VMs, but we also have Hadoop, and we have also other solutions where people can host their data in the cloud, maybe in an Azure data lake, and be able to pull that into a data science solution. So my key here is that we have to all learn how to work together. So data science, there is a future for what I call the data science architect. That is somebody that understands a number of these technologies and be able to put them together. And of course, we know these are only the data science technologies. This does not even speak to operating systems or, you know, tools that people might use on Linux or PowerShell or anything else that we know needs to be there to make a complete enterprise solution. So there's going to be certainly a role. As much as you want to learn, there will be, I think, opportunities out there in a career. This diagram is called the CRISP DM model. The point I want to emphasize in this model is that data is at the center of the story. And that has always been true since this model was developed maybe 10 years ago. There's a business understanding, data understanding, there's some data preparation and modeling. Modeling here is typically what people call machine learning, and then evaluation of the model, and then deployment. In my work, we do some evaluation, we do it with our clients, and then we also deploy our results to a web application that our developers write. And people can deliver those results in different ways. In the Microsoft world, that's often through Excel or now even through Power BI. And that's also Microsoft's general solution, and I'll talk a little later about what Cortana Analytics is. Cortana Analytics is not a product, it's a collection of products. Just like Microsoft Office is technically not a product, it's really a collection of products. Okay, hypothesis. So I'm just going to go ahead and tell you what the difference. There's two words, hyper and hypo. Hyper and hypo. So hyper means above. So if you're hyperactive, you're overactive. Hypoactive would be underactive. And hypothesis means under. So it's the thesis or the idea that's underneath the scientific experiment. So there's some idea that people have that before they go into this cycle, that they're going to have a question. One of the questions that came up earlier is, does the weather affect perhaps product sales? And that's a question. So it's a question that's asked at the very beginning. It's a question where we don't know the answer. It's also a question that might change from day to day. So it's not like a question you answer once maybe and you don't have to ask it again, but you can continue to ask it. Why would that be good news to Microsoft? Because they could charge for people to be running data experiments, or even for things like what my company does in running predictions every week. We need to run it every week because every week we get new understanding. So that does mean, that does indicate where the careers are too in this field, is being able to process data and have that need to continually ask new questions. New questions in the sense it might be the same question, but there might be a new answer because there's new data. So data really is at the heart of this whole thing. When I have talked with higher level executives about this whole process, what I have emphasized is to focus on the data. And if they want to focus their budget, their energy, about what they can do to help this whole data science process, it's in getting better data. Better data, higher quality data, more responsive data. The data is the whole key to making the engine work. I've often sometimes talked about Mark Zuckerberg. One of his genius in becoming a billionaire is he's figured out a way for people to volunteer data. And, sometimes I wonder, where's my check? Why don't I get a check from this? Because, in fact, every time I participate on Facebook, what I'm doing is I'm feeding Mark Zuckerberg's data engine. And that's where he makes his money. Same thing with Google. I put a search into a Google search box, and I'm now training their engine. And I'm now adding intelligence to what they are using and being able to collect. So all these things that we do, we say the internet's free, and people who are able to capture that traffic and monetize it can become really wealthy. SQL Server Analysis Services. And Craig, maybe you could ask the audience a question, just show of hands, how many people have SQL Server licensed where their place of employment or their clients? And just give me maybe an idea how many people are using it now. SQL Server.
So we got 3 hands up.
Three hands out of?
4 hands up, yeah.
4 out of what?
What do you got, 40-something people here tonight?
Oh, 10%? Okay.
Yeah.
What's everyone else using? We got Oracle users, what? Teradata?
Anybody? No answers, per se.
No answers from databases?
Evaluation copies for some of them.
Okay. Well, there's evaluation copies. The good news for SQL Server, you can get a 6-month evaluation copy for free. And by the way, I will mention free software toward the end. If you're enrolled in a college class, or if you have kids who are in school, Microsoft's got a website for you. I will mention that later. Now, the good news about SQL Server Analysis Services is no matter what base you're using, this will plug into it. So if you're using SAS, you're using Teradata, Oracle, if you're using MySQL, or whatever it is, you'll be able to use SQL Server Analysis Services, and I'm about to use it with Excel also. So there's a paper here. This is a architecture paper, which I will recommend for anyone who's working on the backside and wanting to know what the features are for 2016. So you can look at that later. SS stands for SQL Server. AS stands for Analysis Services. So SS is SQL, and Analysis Services is NoSQL. And you may have heard the phrase NoSQL. NoSQL refers to anything that is not SQL. I call it the split personality because this product was branded under the SQL product, but it's not really a SQL product, it's a NoSQL product. And Analysis Services now is the technology behind Power Pivot on Excel, and also tabular model which Microsoft's continuing to invest in as far as making a database is very quick for ad hoc queries. The idea of analysis services generally is for ad hoc query. That's what the purpose of the cube is. And the number one NoSQL database, though, is Excel. So I think that I share the opinion of a lot of people that the world's largest database is still Excel, even despite the Internet. You could consider the Internet maybe is from one aspect, the largest unstructured database, but in terms of structure maybe, or semi-structured, certainly Excel contains a lot of the information that people are using. Okay, there's this website here for SQL Server data mining, and I'm going to go through that first. I'm going to show about the Excel add-in, and then I'm going to show some demos. So there's a data mining add-in for business analysts. This is available from Microsoft. This is free, but you will have to have Office 2007 or higher, or you'll need to have, and you also need to have SQL Server license. So what I'm about to show is because I already have Office, and in fact right now on this particular computer I'm running Office 2016, which I will be happy to say I did this 2 months ago, I think, a month and a half ago, upgraded to 2016. It's one of the most painless upgrades I've had. And it kept everything, and I think, first of all, I did not need to reboot. Secondly, it also kept my Outlook settings when I upgraded it to Office 2016. So this is what I'm going to show through Excel. The data mining algorithms in here come with clustering, prediction, forecasting, market basket analysis, and it's scalable. It's scalable in the sense that whatever you build here in Excel with a little data set could be used to make models that could be put into production for a much larger project. So right now, before you do semantic search, I'm going to show some of that technology. What we're looking at right now is we are looking at SQL Server Management Studio, and I'm going to show on the left side I have on the left side Analysis Services instance open, and I also have a local copy of SQL Server. Now in this particular case I'm running SQL Server 2014, and that's why it says version 12. It says 12 is 2014. It's the same thing. So one of these is regular SQL Server, and then this one here at the top, this one's for Analysis Services. Inside Analysis Services, what I'm going to show is that there's some databases already loaded in my computer. One of them is for AdventureWorks, and this AdventureWorks data set's available on the Microsoft site, so you could download this and load it into your computer and you can see what the results are. So what I'm going to do first, again, I'm in Management Studio. I'm going to browse a model that's already built. So this is already built. The way you build them is one of two ways, and I'm going to show one of the ways later is going to be Excel, but the other way, and actually the main recommended way for building this technology is through Visual Studio. What we're looking at right now is the results of a clustering algorithm. Clusters are like making groups, and I've made the analogy that if you're cleaning your garage or you're cleaning your kitchen, what you're doing is you're making groups. You're often, yes, you are getting rid of dirt, but you're also making groups because you're putting things together that are similar, but they're not identical. You put tools together, or you put silverware together, or you put plates together. Every time we do something like that, it's clustering because they're not exactly identical, but they share a lot of the same characteristics, and therefore that's why people put things together. These ideas of clusters are done on multiple variables, and if I can close this window that popped in front of me, this one's done based on a number of different variables, including commute distance. This was a data table of individuals, and these are characteristics of the people involved. And one thing I will show you right here on this, even on this display, it uses the word attributes and variables. Functionally, they mean the same thing. Attribute, variable, column, feature, really all mean the same thing. And you'll see them often done a different way. So commute distance, education, gender. So this is what it did, is it made groups, and it's showing you now the characteristics of the groups. They're not all going to be the same. Like this third cluster here has a lot of people with graduate degrees, and also a lot of people who are homeowners. But there's also a lot of homeowners in cluster 7, who also happens to have a lot of people who commute 0 to 1 miles. So some of these clusters will be the same in terms of their characteristics, but the technology, what they're trying to do is make these groups as different as they can from each other. So I'm not going to exactly explain everything about what these models are, but I am, at the end of the presentation, I will be recommending some specific books. And again, I'm going to repeat the same thing. I'm on LinkedIn, and I'm also on Twitter. Feel free to reach out to me on either LinkedIn or Twitter if you have any follow-up questions after this presentation. All right. Now what I'm looking at is a forecasting model. Microsoft does something called cross-prediction, where it uses one series to be able to predict another series, and it's also looking for seasonal patterns. And right where I'm holding the mouse, let's say if I go in a little closer here, it's showing the boundary between the future and the past. So right here, this boundary is the future. So these dotted lines on the right represent future predictions, and then what's on the left side represents history. And we do a lot of this even where I work with Predictix. We have our own web technology for displaying this, but basically it's the same thing. So you're showing stuff that's in the future, predictions in the future, and then ideas of what's in the past. Market basket shows things that are predicted together. And some people may have heard the story about beer and, so Craig, again, another question for the audience. How many people have heard the story about beer and diapers being sold together? Beer and diapers sold together. That people buy, when people buy beer, they also buy diapers or vice versa. Has anyone heard that story?
I'm the only one who's heard that story here.
You're the only one who's heard that story. Okay, good for you, because you know what? It's an urban myth. It was actually a thought experiment. And there's another one that's real. And I will take a moment because I feel like sharing it now.
Well, to be fair, I did live in Gastonia for a few years. So. Yeah.
Oh, you did? Okay.
Yeah.
Okay, this story is from Forbes magazine, and this is a story about how Target stores figured out a teen was pregnant before her father did. And the story is, this is a story from 2012. And so what happened was someone went to the store manager, and he was really pretty upset. And the reason was because his daughter was getting these coupons in the mail for stuff that items that pregnant women would buy. So he was pretty upset. So he went to the store and he said, "My daughter got this in the mail. She's still in high school, and you're sending her coupons for baby clothes and cribs. Are you trying to encourage her to get pregnant?" So the manager at the local store, he didn't know what he was talking about. So he looked at the mailer, and it was addressed to the man's daughter and had advertisements for maternity clothing, nursery furniture, and pictures of smiling infants. So the manager apologized and then called back to apologize again. Now, when he called back, the father said, "I had a talk with my daughter. Turns out there have been some activities in my house that I haven't been completely aware of. She's due in August. I owe you an apology." And so what happened was they were able to, because of the large data that they had, they were able to identify not only women who were pregnant, but also be able to predict about what time that woman might give birth. And then they were able to time that with recommendations for other products. And that's what this store is about. So this type of analysis is possible with large amounts of data. And it's something that Target Stores has actually done. So that's what Market Basket is. I'm going to go now to, so I've shown a few things here, Market Basket. There's also some other examples here. And here's a picture of a decision tree. So this is what a decision tree looks like when it's finished. And it's showing here, these are indications of people who would be bike buyers. And it provides a path. And again, I'm not going to read it because that's not the important. The important thing is just to show that this technology is available. I will provide some examples of how to get it. Now I'm going to switch to Excel. And we're going to do this before we have a break here. And we'll have this, we're going to look at Excel, and what we want to look at is this, again, is a table of individuals. Let me zoom in. So we got some individuals here, and you can see what type of information we have for people. We have marital status, gender, income, children, education, occupation, homeowner, cars, commute distance, region, age, and purchase bike. Now, this particular data set was made to predict purchasing a bike. And by the way, if you're going to do data science, you have to have a data set with the answer in it already. You have to have data where you already know if somebody is going to buy something or not. And the idea is, from that data, then you can predict in the future. So the one you wouldn't know in this case would be column M, purchase bike. So I don't know if they're going to buy a bike. What I do know is everything here on the left side. So if you know everything on the left side, then you can identify who might purchase the bike. Why would this be important information? Because the idea here for an organization, we were earlier talking about Wells Fargo and being able to perhaps promote certain products that they have. So some people, based on their demographic characteristics, might be more likely to purchase, one of their financial products, and that would be the use case for something like this technology. But I'm going to change this. So actually, you could predict anything that's in this list, given that you have all the other columns. So I'm going to switch this, and I'm going to do prediction of marriage. So we have marriage here in column B. Again, the use case would be searching for missing data. There's often missing data in databases, and you'd want to be able to fill that out or be able to tell whether or not someone actually might be married. So what I'm going to do is I'm going to use this Analyze tab. Now again, this is connected to my analysis services. I'm going to test my connection. It says it succeeded. So it's connected again to something else. And the point there is that we're not just in Excel. Okay, we have something on the back end. And by the way, you could tell this is Office 2016 because the top bar here is a little darker in green color than it is for the 2013 version. I'm going to do something called Prediction Calculator. I'm going to test their marital status. I'm going to see if they're married. What columns are going to go in? I'm going to use all these columns and click OK, and then I'm going to click Run. So right now it's taking that list, and I think there's about 1,000 on this list, and it's going to predict whether or not someone is married. And I'm not going to go through every part of this, but I'm just going to focus on one area just to show how this works by making the screen larger. So this works like a point system, and if you think of it kind of like a credit score. So here's gender, female, male. So if you're male, now this does not have to do with your friends or people you might know in your social circles. This is just the people who happen to be on this table that I'm looking at. So female, male, if you're male, you get 28 points. Okay, the next thing you go down, income, and then you do the income, and then you get so many points. And then you go children. How many children do you have? Then you get so many points. Then education. How many points? Now all these points were generated dynamically. These are not stored in a database somewhere. They were just generated dynamically from that table that I just used. Then you add up all the points at the bottom, and if you have at least 529 points, then it indicates that you're married. So that's the way this scoring calculator works. Now I need a volunteer. So Craig, maybe you can identify someone who wants to volunteer. Come to the microphone, and they're going to pick answers here, and then we're going to add up the points. Now you don't have to pick for yourself, okay? You can pick for yourself, but you don't have to, because you're going to pick gender, income, and all this other stuff. But so Craig, you're going to identify somebody who wants to volunteer for that. And you just tell me your name when you come up. This is easy. All you do is pick it. There's no trick here.
Thank you for asking me to do this today.
Okay. Female or male?
Female.
Okay. Okay, and then income?
97,000 to 127,000.
Okay. Children?
2.
Education?
Partial college.
Occupation?
We don't see it yet. Stand by. We're
Yeah,
still
clerical.
Okay. Now it's just painted the screen. Skilled manual. No,
Okay.
you can't. No, you can't make that kind of money. Let's make her professional.
Okay.
Yes to homeowner. Commute is 12 miles. Oh, yeah, my choice.
Oh, it's cars. Cars.
Oh, cars. 1.
Okay. Commute.
5 to 10.
Okay. Region.
North
We
America.
get North America. Age.
That's fine.
Fine. Purchase the bike, and we're talking about a manual bicycle, not a motorcycle.
Yes.
Yes. Okay. 416. And according to this, prediction for marriage is false. All right, but that's only part of the story. Now here's the amazing part. There's a certain implied contest that's happening right now, and you just picked a combination on the screen. Now we're going to take that, and I'm going to take a picture of it. And what I'm going to do is I'm going to look for this person in my original table. Okay, once that screen comes up. So I'm going back to my original table, and to give you all an idea of how many observations we have, about 1,000. So there's about 1,000 individuals in this table, and what I'm going to do is I'm going to try to find that person in the table. And so far, every time I've done this, nobody's done it. So, but it's going to make a point. And then we'll go to our break. But first of all, so I'm going to see, first of all, I'm going to go to gender, and I'm using the Excel table, so I'm going to be able to choose here on the boxes. Now, income is going to be 97. Now, what happens is I'm just choosing the round numbers because the round numbers are the ones that show on the table. Then I'm going to go to children, and I'm going to pick 2. Oh, I only got 3 left. I didn't get very far. Okay, partial college, I got 1 person left. And professional, yeah. Homeowner, okay, already it didn't do it. So homeowner, no, and this one's cars 3. So this is a similar person that was in the data, but what happened, and this person is single. So a very similar person to the one chosen, and this person has to be single. That fact influenced the final answer because it you know, this is the evidence we're going from is what's in the table. And the point I want to make here is that this data mining or machine learning is not drill down. It is not drill down to try to get what the person on the right here is from the original data. The idea here for data science is that we are able to make a prediction about a person and whether or not they will purchase a bike, even if they don't actually exist in our database. They don't exist in there, but all the values that this person has do exist, and we also have the final answer about whether or not they're married. So because we do, therefore we can cover, now I'm going to give you the math language, we're going to cover the entire space of possible combinations that are possible from the data set, the original data set, and then I think we just got disconnected, but I'm back, right? Craig, can you hear me?
Yeah.
Okay, so let's go ahead and take a break. So 15 minutes. All right, so we're ready? Are we ready?
We're ready to go.
Okay, excellent. So thanks for that break. Enjoyed the music. I could barely hear it, but I did identify the Paul Davis song, Cool Night. So thank you very much for that musical performance. We had an event here in Atlanta where we hired a band for our after party. So love to hear live music. I'm going to give an example on the screen here as we go back into our demo here. You all may or may not know that the people at Bing have a good team of data scientists, and they've been doing predictions on things that are in common knowledge. Here, this article's from November 10th. this is Bing predicts kicks butt in NFL Week 9 with 9 out of 4 performance. So they correctly picked 9 out of the 13 games that they picked for NFL Week 9. So Craig, how many show of hands? How many Carolina Panthers fans? How many Panthers fans in the house?
We're looking at about 75% in here.
75%, and of course, I respect anyone who's got their loyalty for whatever reasons.
Well, we have had a really good season this year, so, you know.
Yeah, so as you all may know, Panthers are going to be playing Titans Week 10, and as you see on the screen here, Bing is already predicting that Panthers are going to win this weekend.
Don't jinx this, man.
Panthers are going to win. It's giving you 70%. And we can see some of the other games being predicted here. So if you are an NFL fan or if you are participating in some of these fantasy sports leagues, you might find it interesting to see how Bing does versus some of the other places where you're getting predictions. So you can follow that for the season. So we got that idea. Bing's also predicting other things. They have predicted elections. They predicted the Scottish vote. Scotland voted for independence, and the vote came out to be no. But Bing's also predicting other things, so you can go see what Microsoft's doing. They're using these examples to engage the public in examples of data science, and these are applied examples, so you might want to go look at that on your own. I'm going to go back to our slide deck and show some more of these technologies. The next one here is called Semantic Search. This technology is a text technology, and so there's both quantitative and qualitative, and most data is in text. And if we had a transcript of this meeting and of the, I guess now 18 years of this group, if you had a transcript of the entire 18 years of presentations, you'd have most of the data would be in text, even though it's a technology group. And that's true for a lot of things in science and technology. So a lot of data that we have is in text format, and increasingly there's now applications and ways to be able to apply machine learning to that, to those types of data sources. And this is one of them. In SQL Server, it's called a file table, and it's a table that's on the Windows disk, but it's managed by SQL Server. So it's completely done with these special tables. They're accessed as if they were stored in the file system, meaning from the outside it looks like a folder, but it's actually managed in terms of permissions from SQL Server. And it's based on the SQL Server file stream technology. And what you can do with this is you can take your varchar or nvarchar fields from a database or Office documents or PDF, and you can put them into this folder, and then you can have it look for information. And the way it works, you have your documents, you have to have something called iFilters, and it goes through and it builds 3 things that you need for this, these 3 indexes. So an index is a fast way to get information, and that's what we want. If we just had these documents, if I had a list of documents, I don't know where anything is, it's hard to find it. The idea of an index is it gives us a quick way to find information in a particular document. These are the languages that are currently supported. Of course, English is on this list, but also 5 variants of Chinese are on this list. Then you have Spanish and other languages. And the idea here is that this product will scale linearly. So the horizontal axis here is the number of documents, which goes to 1 million, and then the vertical axis is the time in seconds. And what it shows is that as you add more documents, it's going to scale linearly. If you or I were to go home and try to write such technology, it would probably scale exponentially. And this ability to scale linearly is why Microsoft purchased this technology about 5 years ago for $200 million. People in the technology business, you know, they always want to make that next company that Microsoft might want to be interested in and maybe buy it. If not Microsoft, then other companies that buy companies. I'm going to show a little bit of this technology. So first I'm going to go to my Windows desktop, and I'm going to show you the folder here where I have several things. One is I took some documents here. These are PDF documents of the R language, and if I've opened one of them, you'll see that it's a PDF document. What I did was I took this PDF document and I just copied this. These are free documents that just come from the internet, and I put them into this folder. And once they're in this folder, now then SQL Server will start indexing it. It'll start breaking it down. The way it can do that is because it's got the I filter for PDF, so it knows how to read a PDF document, and then it can put it into an index. And once it's in an index, then I can retrieve the information of the SQL Server query. And I not only did R, but those R documents, which is about the R language. I also downloaded Wikipedia, and as you all may know now, is that you could download Wikipedia. You can download the whole thing. It'll be a zip file. It'll take a while. And once you download it, then you can parse it into files. And I did this for a good number of files. And here's some of the files that came out of it. And I just saved them as HTML files. And I got a good cross portion here of what is inside Wikipedia at the time I did that snapshot. Once I do that, then I can come into SQL Server and I can run a query. Now what I'm going to do is I'm going to look at specifically the query here is all stored in a SQL Server database. This particular one is the database where I read in those queries for the R language, those PDF documents. And once those are in here, then I can look for properties of the documents. First I have to switch the database. So let me go back. No, I'll just do it manually. So I'm going to go to the right database, and I'm going to just run a query. I'll just do this there.
There's a little bit of a delay. Do you have the
okay.
Do you have the screen, the window all the way to the right?
Yeah, it's all the way open, so it's not showing yet.
There it goes.
Okay. Maybe it'll show in a second.
It's showing, but we're not seeing the left corner because we don't have a wide screen. We've got a...
Okay, no worries. Can you see the query that's highlighted in blue? Yes, no? No.
Yes.
Yes? Okay. So there's a query here, and this query says get documents and contain the keywords data and SQL. And so it will look where the words data and SQL happen to be close within 5 positions, and false means it doesn't have to be in that order. So in other words, SQL could be first and data could be second, or data could be first and SQL could be second. So it'll break it down into individual words, and then it'll look for those combinations of words. Then it will tell you what document it's in. Now it doesn't do everything. I mean, it's not going to read the document, but what it does is enables you to put, maybe a large number of documents through here, and either PDF, Office documents, PPTX, DocX, XLSX, and be able to index them. Does anyone have any questions on that before I go? I'll take a quick question.
Any questions? I think we're good to go.
Okay, let's go. Microsoft Azure Machine Learning is one of the hot new technologies, and it's one of the technologies generally connected to Azure. And I will recommend that if you're planning, as I am, still working 5 years into the future and in the IT industry and working with Microsoft products, then you do need to learn more about Azure generally. There are a lot of pieces to Azure, and it's growing like every day because they could just roll out a new product. Every time I go back, I see improvements to products that are already there and also new products. What we're going to look at right now is Microsoft Azure Machine Learning. And this is a diagram of SQL Server 2016. What I had mentioned is that the R language now is available in the CTP3 download. In fact, you don't even have to download it. If you have an MSDN license, then you have already Azure credits, and you can go in and look at it now. Or you can also sign up for Azure now for free, and you'll get automatic free credit without having to pay additional amounts. Now, you have to put your credit card in there, but you can just stay within your free amount. And spin up an instance right now. Going to Azure, you can make a virtual machine with SQL Server 2016, CTB3, and then look at the technology for R language. What I want to point out is when this diagram came out, they had the picture here of this data scientist, and it was very close. If you look at the similarity between this little icon that's on the Microsoft document and the picture that I had taken a year before this document came out, was pretty close. Of course, I don't have the tie that the guy had on the little icon picture. Craig, hopefully you can see this. Okay, so I have a screen here. There's a technical analysis of what Azure Machine Learning is. There's a website I recommend for learning more about the R language. It's datacamp.com. There's also Python in here, which is I have a link for that, and Azure Machine Learning Portal. And before I show F#, I'm going to go to the website here and show a little bit about Azure Machine Learning. We're going to be on this site, and we're going to reload because it's probably disconnected from the time I connected earlier. Let's try to get in again. No, do it again. Different screen. Let's wait for it to come up. I brought it up earlier, but that was at the beginning of the program, and it timed out. It doesn't want to do it. So let's try it again. Okay. We're going this way. So Microsoft Azure is accessed completely through browsers, and that means that you can access Microsoft Azure from any operating system. You could be on a Mac, or you could be running Linux, or you could be running Windows, or on your iPad, or whatever browser you're using, and access Azure. Mine's not really coming up, and it could be because we got a lot of things going on right now. I don't know. I'm going to try to bring up another browser. Let's try it again. Not found. Why is it not found? That doesn't make sense. Comes it right there. Huh. All right, so you know what? I can't get on right now. So let's move on, and let's go to F#. What is the motivation for F#? And here's a picture that I grabbed off the internet of mutants. There's apparently a movie on mutants from some years back. These mutants might be more familiar to you. And there's a problem with some computer languages, and that is that they're mutable. Mutable meaning they can take on different forms. And from a programmer's perspective, that convenience might be a good thing, because you can have a variable that may be a type of numeric string, or a numeric, or a string, or go back and forth between them and change format, or change to something else and mutate to a different type, and that might be an advantage. But in a lot of computer settings, that's not an advantage. So there's some languages now, functional languages, like Scala, like F#, that are immutable. And the advantage of immutable is that it gives people the chance to scale their technology. So like what I described earlier, we're doing with logic blocks, because it's a functional language and because the variables are immutable, it allows the programs now to be scaled across multiple machines. I'm not going to give a full proof of why that's true, but there are a number of videos available on Scala and on F# that demonstrate some of the differences and why that's an advantage for parallel processing of the type I was talking about that I'm using in my high volume work. Do you need to use this on a daily basis? Probably not. And I think most people, they're going to be able to do data science with a smaller project, such as the technology I showed earlier with analysis services, or that I was wanting to show with Azure Machine Learning. But F# would certainly be a candidate for thinking about functional programming and for doing high-scale volume processing. Does anyone in the audience know what REPL stands for? Technology trivia question.
Doesn't look like it.
No. Okay, so it stands for Read, Evaluate, Print Loop, REPL. And it represents kind of the way I learned how to program with the command terminal window and running BASIC. So you type something in the terminal and you get something back. And actually, this is how the loop is. First it does a read, then it does an eval, then it does a print, then it does a loop. And that's what's on the outside. So that's what is available in a REPL window. So here's some of these mutable languages listed here. .NET, of course, now open source altogether, in case you didn't know. F# was always open source, but now .NET entirely is open source. And some of the immutable languages are Scala and F#. There's some resources, and I have some links to that. And before I show my back office slides, I'm going to go to Visual Studio, and I am going to show a script. Now, I'm going to tell you where I got this script first. I got this script from Matthias Brandewinder's site on GitHub. So a lot of people are using GitHub now. Microsoft's on GitHub, if you didn't know. Before, everything was parked in Codeplex or some other site, but now Microsoft's beginning to park things in GitHub. And it's good to go in here and make an account if you are a developer or interested in things. So Matthias wrote a book called Machine Learning in Action, which is a book about F#, and the code that I'm about to show comes from this GitHub repository. What he did was he did some coding in C#, and then he also compared what it would take to code the same thing in F#. So that's what he did for his project, and for his book, actually. So what I'm showing on the screen right now, I'll just zoom in to give you an idea what F# looks like. So here's, at the beginning here, here's where some of the references are made at the beginning of the code. And then, as you notice, all you do in F# is you're indenting, and also there are curly brackets. I mean, we see them right here, but there's not the same level of curly brackets that you see in C#, and also that there's no line termination symbol. So it reads a little bit more clear. And what happens too is that you have these little pipe functions. So it's got a pipe with an arrow, and what it means is that you take the results from one line and then it goes to the next line, and then it pipes to the next line, and it pipes to the next line. So what it's doing is, instead of writing 4 lines, what I'm doing is I'm piping it from one line to the next, and that's how the code writes. So F# is a full member of the .NET community, so you can take this and make DLLs, and you can access the entire Windows operating system with your text. This particular one, this is called Digits Recognizer, and I'm going to go ahead and start. Let's see. I don't know if I can do that because I may have to set this as a starting project. Let's see. Yes, I do. Okay, now I can start it. No? No. Okay, that is not working. Oh, you know what I need to do is I need to open the window. So I'm going to open the window for there's a REPL inside Visual Studio, and it's the F-sharp interactive window, and that's what I'm going to do now. So I'm going to open up that window. Let's see. Go to the right place. Let me make sure I'm running the right script first. I see two scripts got open here. It's the visualization, and this one. Okay, here's the interactive window. In fact, I'm going to bank it right there. Let's see. See if I can get this to go. Yes, no? Is it going to go? There we go. All right, so what it did is, and I'm not going to explain the entire code here, but what it did is it took these digits that were written on the screen, and what it provided at the top is a description of what it thought this image is. So this one, it says it's a heat map 1 and other 0. So it's kind of seeing a 1 here through like a slash and then a 0 on that screen. And then here's a heat map here with a 0 and another 0. So it's like a donut inside a donut. And that's what it was able to classify. This one, it looks like a 1. So that's why it says this is a 1. And this one's a 0. So it said it did that recognition here, exercise there, and found that that one was a 0. So it does these digits recognition. Now what's important about these predictions is that they're coming from code that's really not that long. And you can go through and you can download this code yourself. But I'm looking at the screen here. This one only has 60 lines. And then the other one here has 60 lines. And it's doing it using Euclidean distances. So, and then other techniques. But what happens here is that it uses these few lines to be able to do those predictions, and then reads those pictures, those images were stored in a file. Then it reads a file in and then decides what it is. And right here, let me zoom in. So I'm going to zoom in the screen. That's where here it says draw, this is a 0 or this is a 1. And that's going to decide. Or it's going to say heat map 0 another 0, or heat map 1 another 0. So it's going to do one of these messages depending on what the image is. So that's kind of how that works. So that's a little bit of F#. I'm going to do now the back office implications. What does this mean in terms of running the technology? So SQL Server Analysis Services, what it means for that is someone would have to have SQL Server. There are different editions. The ones I recommend are Business Intelligence and Enterprise Edition. There is a developer version available like on Amazon. You can get a full version there that only works on one machine, and it costs about $50, $60. I don't personally do that because I have an MSDN license. So I use my MSDN license, and I have a version of SQL Server. I earlier mentioned about talking about free software, and I'm going to do that right now. So again, if you have kids who are in school, or if you are enrolled in a class, then you can go to DreamSpark. Microsoft DreamSpark is a website that will enable students to have access to a lot of SQL technology, including SQL Server. And in fact, that's even here on the first page. There's a version of Visual Studio, SQL Server, and Microsoft Azure. And although I wasn't able to bring up the Azure Machine Learning, there is a free version of that that's available without a credit card. So the version that's available on the web could be used by students in school on their school projects of Azure Machine Learning would be free.
Yeah,
the implication, go ahead.
I think you just need to have a valid school email address in order to get that. Yeah.
Yes, you need to have a valid school, and they're looking for a .edu address, so it does not require the school or institution to participate, all you do is need to have the email address, and you can see what the terms are on DreamSpark. DreamSpark.com. Again, I would recommend that for your kids, and you can have the software available for a lot of Microsoft products. So we're not just talking about SQL Server, but other things. Okay, back end. Okay, we got SQL Server license. Now, if you are an administrator, you're going to have to set up Windows authentication and put people into authentication groups to enable analysis services. There is a difference between development and production servers. I recommend all the data science model building be done on development servers, and then only once they're built, then you put them into production. The Excel add-in, now you need, for that one, you need 2007 or higher, and I can definitely recommend going to 2013 or higher. Now with Power BI is really the version where people need to be. Power BI or an Office license can be now done through the web, and when you sign up through the web, it enables you to download the software and then install it on your own computer. So if you don't have Office, you can get it through an Office subscription. And of course, keep in mind that I just said DreamSpark, so there's DreamSpark licenses out there also. Semantic Search requires SQL Server, and this is good for volume processing, but this on the back end is going to require somebody to be able to set up the file tables and be able to monitor that process, for how many documents. Someone has told me that type of technology is often used in e-discovery, which is a legal process of looking through a large amount of documents or emails. You have these things where people go through large numbers of emails or documents looking for information, and that's what Semantic Search can help with. Azure Machine Learning, again, students can sign up for that without a credit card, and you have the ability to do R and Python. Sorry I wasn't able to show it. We're just going to move on, but I would certainly recommend, there's a number of videos on Azure Machine Learning that are available on the web. If you take a look at them, or you can email me about that. And one thing that's very good about that, as far as the back office story, is that these can be quickly deployed. So I can start a virtual machine in like minutes. It doesn't start instantly. It still has supervision. But if you compare that with the situation of having to set up a machine on a physical server, that's a lot more work involved. And of course, we have the cloud issue. Whether your data can or should be in the cloud is a separate topic. We have our team, working with our retail clients. They ensure that through, processes that make our clients happy. I mean, the clients do know where we're putting their data, and they know that whole story. So we work with clients to help them understand the security implications of working on the cloud, including Amazon AWS or Microsoft Azure. And then F# is all open source, so it's all .NET development. The back office story there might be having to do with code reviews. And I had some work that I'd done with Centers for Disease Control. It's very difficult in a government agency to write software. And the difficulty has to do with a number of reasons. One is just assuring that it works. Secondly, factoring in disabilities, and they're very sensitive to making sure that people with disabilities can access software and websites. And then thirdly, just the general security issues of opening government networks. So for those reasons, there's several layers of approval that go through just for someone to be able to write code in some organizations such as federal government. Okay, so here's some of the resources. Again, I'm going to be sharing this deck. I'm going to remind everybody about connecting with me on LinkedIn or Twitter at MarkTabNet. At the beginning of my Twitter feed, I have a pinned tweet of 60 free data science books. And some of them have to do with Microsoft, and some of them are just generally free. And I'm not talking about the shadow web where you can get anything for free, or it seems like it. I'm talking about authentic, these are books that the authors wanted to share and make their books available on the web. So one thing I do recommend is ACM, and there's a conference called KDD. If you want to go to a conference, that is a possible conference. Book on the left is Data Mining for Business Intelligence. This is written for business users, and that's one reason I like it. The one on the right there is about the R language, same authors, one of the same authors, and that has to do with forecasting with the R language. The book on the left here, Data Mining with SQL Server 2008, is considered the best book on that technology. And it was written by the people who wrote the technology, so that's how you know it's the best. And it's got information in there that's not in MSDN. So it complements MSDN. It just goes beyond what was presented in MSDN. The book on the right about expert F-sharp has to do with the F-sharp language. This book, next book, has to do with Microsoft Azure, and that's now in second edition. It's an excellent book, describes where that technology is. The one on the right is a free book, and free book by Stephen Elston, who, by the way, recently taught a class at edx.org. I guess it's edx.org. I took that class as a 5-week free class. I took the certificate option, which meant I paid them $50, and they certified my participation in that class. But anyone can take it for free. It's edx.org, and excellent course on data science applied to Azure machine learning. There are a number of free courses available at edX or Coursera, or don't forget Khan Academy. Khan Academy for basic math, Coursera and edX for data science. It's got a lot of great courses and free. Matthias' book on the left side about F-sharp, and the book on the right about T-SQL window functions, which I think are important for making features. And I mentioned DreamSpark. There's also BizSpark for businesses and some other things. And this is my friend Jen Stirrup and I doing an arm wrestling contest. She's from Scotland, so I'll just tell you that the outcome there, she won. But she's a board member of PASS, Professional Association for SQL Server, and we are leading a virtual chapter on PASS data science. Now, we haven't produced any sessions lately, but now that the PASS Summit is over, like it was last week, we now both have a breathing room and be able to produce some new sessions that we're going to be sharing online and on our YouTube channel. So we're going to make those available. We'll have live online sessions, but we're also going to be putting them on YouTube. So that's all I have. Thanks everyone for coming, and I'll be available to take questions. And other than that, I certainly appreciate having the chance to present this topic tonight.
Okay. Can you hear that?
Yes, thank you.